Alright, this is a question you'll get that looks at kinetic energy and elastic potential energy. So I'm not going to read through this whole question. If you want to read through it, please read through it now before I continue. I'll head straight to part A, which is calculate the magnitude of the spring constant K with an appropriate SI unit. So straight away, I can see that the elastic potential energy is 18 joules. So I'm using the elastic potential equation here, and that's equal to half K because we're finding K, and the extension or the displacement 0.38 meters. And we can rearrange to find K, which should be 249 Newton meters. You should always include your units, even if it doesn't explicitly state that. You can lose or gain marks based off of if you do or do not. So always just try and use or include units in your answer. Next is determine the kinetic energy at the point of the block at point A. So we know at this point here, the elastic potential energy is 18 joules. And we know that this plane up until A is frictionless. So that means all of the energy that's stored here at point A will be turned into kinetic energy. Remember, kinetic energy is the energy of a body in motion. So all this energy, all this 18 joules of elastic potential energy gets converted into 18 joules of kinetic energy at point A, because this is the point of equilibrium, and that's where no forces are acting on the spring. So all this is transferred from 18 joules of elastic potential energy to 18 joules of kinetic energy. So it's just 18 joules. Calculate the speed of the block passing through the point A. Well, we know that the kinetic energy of the system is 18 joules. So if we just look at the equation, we can sub in 18. And we know the mass because it's given to us as 2.3 kilograms. And a little bit of rearranging to find the velocity gives us around 4 meters a second. And well, that's your answer. And now we have to consider frictional forces. So we're told that between A and B, friction is non-negligible. So the coefficient of friction is non-negligible, so there is some friction here. And we can see that some energy is lost because obviously if this was just a frictionless plane, the velocity would remain constant. Here we can see it drops down to 1.6 meters per second. So what I'm going to do is I'm going to find the kinetic energy at the start at point A, and then the kinetic energy at point B, find the difference of that, and the difference of that is the energy lost due to friction. So at point A, we can just sub in the values that we have. So it's half mass velocity squared, which is 4 squared, and so that's around 18.4 joules. And then the kinetic energy at point B is 1.6 meters per second, is 2.944 joules. And if we find the difference of that, that's just 18.4 minus 2.944, and that's just 15.456 joules. So that's the energy lost due to friction. And so what we can do now is we can use work equals force times displacement. And so we know the work is 15.456 and we don't know the force, but we know the displacement is 0.72 because the distance from point A to B is 72 centimeters. That's 0.72 meters. Times that by force, and then just rearrange to get force is around 21 newtons. And that's your answer there. It's 21 newtons. So an overview of this question. This question is really nice because it gives you a step-by-step to find the final answer, pretty much. So what we did was we first found out the spring constant based on the fact that we were given elastic potential energy and we were given the compression or the displacement of the spring. So we found the coefficient, or the K value, the constant value. And then from there, we determined that the kinetic energy is all transfer from elastic potential energy at point A. So it's just 18 joules. And then we found this velocity of the object, which is just 4 meters a second, if you just plug in and rearrange the values. And then we found the difference between the kinetic energy at point A and B in order to find the energy lost due to friction. And from there, we just plugged it into work equals force times displacement. We know the displacement is 0.72 meters, and we just rearranged to find the force, which is 21 newtons. I hope that helped. See you later.